మేడం అన్మ్యూట్ చేసుకోండి. మేడం రాధికా సేనాపతి మేడం
సార్ సార్ చెప్పండి సార్.
అన్మ్యూట్ చేసుకుంటున్నారు కదా?
ఎస్ సార్, అన్మ్యూట్ చేస్తున్నాను.
ఓకే. Sir, good morning, sir. PSN, sir. సార్ మీరు అన్మ్యూట్ చేసుకోవచ్చు సార్, చెక్ చేయండి ఒకసారి. సార్ టిఎస్ఎన్ సార్. హలో హలో సార్ టిఎస్ఎన్ సార్, ప్లీజ్ అన్మ్యూట్ సార్. Sir, please check whether you are able to speak or not. Sir, we would like to check whether it is audible or not, sir. Can you please unmute?
You are audible, sir. You are very much audible.
Yeah, yes, sir. Sir,
అంటే సడన్ గా నాకు మ్యూట్ అయిందన్నమాట, నేను చూసుకోలేదండి ఇక్కడ, అందుకని మీరు మాట్లాడుతున్న తర్వాత థ్యాంక్ యూ వెరీ మచ్ సార్. థ్యాంక్ యూ.
సార్ అది మీరు కూడా యాక్చువల్గా కో-హోస్ట్
Sure.
Yeah.
So for this event, how many attendees are there, Mr. Chaudhary?
Sir, we have 61 authors, sir, who are the participants actually.
Okay.
And besides that, we both RIT and RE, the Raghu Institute of Technology and Raghu Engineering College, both the colleges are hosting this event. So we have all the faculty from both the colleges, and put together it is around 220, sir. And we have some IEEE student members also who have joined. We have student branches in both the colleges. So
Okay.
the ComSoc and SPS student members have joined. So all these people would be joining through the YouTube live streaming, sir. And
Okay.
and the same live streaming is also available on the RIT IEEE student branch website also.
Okay.
Just to enable and make it convenient for us to stream it uninterrupted meeting, we have arranged a separate channel for them. So they would be joining online on YouTube as well as this my college website. While
Gotcha.
there are few faculty members who would like to interact if they are interested, so we ask them to join through the Google Meet.
Okay. That's great.
Yes, thank you. So meanwhile, you want to check this screen sharing?
Sure. Yeah. Let me just give me 1 second here.
Yeah, yes, sir. Now you have the privileges, sir, actually.
Okay. Give me 1 second here.
Yeah, okay, sir.
Okay. Let me share the screen here.
Yes, sir.
Kiran garu, good morning, sir.
Good morning,
This is Satish Ram Chaudhary.
Satish. Yes.
Yeah.
Yes, sir.
Okay. Can you see my screen?
Yes, sir. Yeah.
Yes, sir.
Okay,
Yes, sir. We can
great.
see.
That's great.
Yeah, it is in the presentation mode, I believe, sir.
Okay.
Yeah. So they helped us in getting this conference materialized finally, and the active people in this conference are the IEEE student branch members of both our Raghu Institute of Technology as well as Raghu Engineering College. And today, for this keynote address on the day two, we have along with us Principal Professor S. Satyanarayan Garu, Principal of Raghu Institute of Technology, and Professor C.H. Srinivasu, Principal of Raghu Engineering College. And along with us, we also have our Vice Principal, Professor P. Satish Ram Chaudhary Garu, who is also the head of the department of ECE at Raghu Institute of Technology. And along with us, we also have Dr. T.S.N. Murthy Garu, who is the chair of ComSoc and SPS joint chapters of Vizag Bay section. And we also invited Professor S. Lakshmi Narayana, chair of IEEE Vizag Bay section, and also Dr. Sri Chisti, secretary of IEEE Vizag Bay section, sir. So yesterday during the day one we have done we had a splendid response from the participants, and there are a good number of participants offline for the session. The inaugural function is graced by Professor K. Hemchandra Reddy Garu, who is the chairman of APCHE, and my chairman, Sri Raghu Kalidindi Garu, he is also present, and he is also very happy looking at the keynote addresses listed on the website, and especially he conveyed a warm welcome to you, sir. Because he is delighted going through your resume and the biodata, and the theme of the talk is also very much impressive, because we are going through a good time, in fact, establishing and strengthening our IEEE student branches and student memberships in our college, and this is definitely going to be an inspiring talk to all the student members. And all the student members of both the student branches, they have joined online through the YouTube link, sir. They are not available on Google Meet, just we have restricted to only the participants. So with your permission, I'll request Radhika ma'am.
Yes, sir.
Radhika ma'am, can you please introduce the speaker to the audience?
Yes, sir. Yes, sir. Thank you, Dr. Chaudhary sir and Dr. Samir sir, for giving this opportunity to me. A very good morning to one and all. I am very happy to introduce today's keynote speaker, Dr. Kiran Gunnam Garu. Dr. Kiran Gunnam sir is a distinguished engineer in machine learning and computer vision, Western Digital, USA. He is an innovative technology leader with vision and passion who effectively connects with individuals and groups. Dr. Gunnam's breakthrough contributions are in the areas of advanced error correction systems, storage cache memory systems, and computer vision based localization and navigation systems. He has helped drive organizations to become industry leaders through groundbreaking technologies. Dr. Gunnam sir has 86 issued patents and 100 plus patent applications or invention disclosure on algorithms, architectures, and real-time low-cost implementations for computing, storage, and computer vision systems. He is the lead inventor or sole inventor for 90% of them. Dr. Gunnam sir patented work has been already incorporated in more than 3 billion data storage, Wi-Fi, and 5G chips as of 2020, and is said to continue to be incorporated in more than 500 million chips per year. Dr. Gunnam sir is also a key contributor to precise localization and navigation technology commercialized for autonomous aerial and space docking applications. His recent patent pending invention on low complexity simultaneous localization and mapping and 3D CNN for object detection, tracking, and classification are commercialized for LiDAR camera based perception for autonomous driving and robotic systems. His more recent inventions on machine learning accelerators have 2 times the savings versus the state of the art. Dr. Gunnam sir received his MSW and PhD in computer engineering from Texas A&M University College Station. His world renowned number balance between storage analytical ability and pragmatic insight into implementation of advanced technology. He served as IEEE Distinguished Speaker and Plenary Speaker for 25 plus years, events and international conferences, and more than 3,000 attendees in the USA, Canada, and Asia benefited from his talks. Dr. Kiran Gunnam sir is member of Board of Governance of IEEE Circuits and Systems Society. He is also the chair of IEEE Cash Standard Activities Subdivision. Dr. Gunnam sir has been involved with the IEEE Standard Association since 2013. Dr. Kiran Gunnam sir is a recipient of the Valley ML Distinguished Technical Achievement Award for long-lasting contributions to architecture and algorithms of real-time signal processing, communication, and machine learning systems that enabled ubiquitous computing. A warm welcome to you, sir.
Thank you, ma'am.
Thank you, sir.
Okay, thank you so much, Ms. Radhika and Mr. Chaudhary and Mr. Satish and Mr. Murthy, and also thank you for the host, Mr. Raghu, sir, who is the chief of these colleges. And I'm actually very happy to present in this event. So actually, like I studied my bachelor's in JNTU Kakinada. So it's a great pleasure to talk in this event held in my own native region. And thank you for Murthy for introducing to this great group of people. Thank you.
Yeah, thank you very much, sir.
Definitely.
Looking at the biography of yours that we have published on the website, the chairman really gave a big applaud to the way we have arranged the meeting, organized this event. Really, this keynote address and your presence in the conference is going to be an added advantage, going to give a lot of mileage to the conference. In fact, especially the message that you are sending from this platform on behalf of IEEE CAS is definitely going to inspire many people, sir. Because there are several student branches and several professional members who have joined to any chapter membership. So I hope definitely they get benefited by this and they get even inspired by this. So we can start the meeting, sir.
Okay, that's nice. Thank you again. Let me see whether I can turn on my camera here.
Yeah, yes.
Okay. Hope you can see my screen.
No, sir. No, sir.
Yep.
Screen not shared, sir.
Not it. Okay. Give me a second. Yeah. Are you seeing my screen now? Like the slides?
Yes, sir.
Yeah. Yes.
Okay. That's great.
Yes.
Okay.
Yeah.
Thank you again for the organizers for having me as part of this event. So in this talk, the idea is to introduce this new division we recently formed in IEEE, Circuits and Systems Society. So this subdivision is called IEEE CAS Standard Activity Subdivision. It's abbreviated as SASD. So it's within the IEEE Circuits and Systems Society. So IEEE, as I explained in the next slides, has more than 400,000 members. And part of this presentation, I will be reusing the slides from IEEE introduction presentation, as well as I reused the slides from IEEE SCA presentation. SCA is the Standards Association, which is the organization within IEEE that is driving the standards. And also I used the content from the webpage IEEE SCA Developing Standards, and also included some additional commentary about CAS. And some of the views in this presentation, they should be considered as personal views. These are not a formal position or explanation or interpretation of the IEEE. So this is required as per the IEEE SCA Standards Board Operation Manual. So I hope most of you know about IEEE by now, given that Dr. Murthy and his colleagues are doing a great effort in having several of IEEE events in Vizag Bay Area. So as you might know already, the IEEE's core purpose is to foster technological innovation and excellence for the benefit of humanity. And IEEE, we recently also had a big presence in Consumer Electronics Show in Las Vegas. And so most of the technologies that are developed now has some relation in terms of the work published in IEEE or the work, for instance, the several innovators have done published in IEEE. So for instance, my work also, we published in IEEE conferences. And so it's a great forum to publish your work and spread the knowledge to the community. So IEEE has almost 419,000 members and in more than 160,000 countries. And more than 60% of these are from outside US. And we have more than 124,000 student members. And I can skip some of the statistics, but I think the key aspect is that the IEEE is a member-driven society. And students form a very key role in this society. And so we have 39 technical societies, and there are 7 technical councils, and these represent the wide range of IEEE technical societies. And also, we have more than 5 million documents in IEEE Explore digital library, and this has more than 15 million downloads each month. So most of the universities have access to IEEE Explore. And so this is a great way to know what's happening in the technology. And also, if you're performing research, this is I would say is a necessary tool to know what's happening in your field, and also to know what is the state of the art as well. And the other key aspect is that the IEEE has an active portfolio of nearly 1,200 standards, and also more than 900 projects under development. So what it means is that if you're using the Wi-Fi on your phone, that is one of the fruits of the labor of the IEEE standards group that has done the 802.11 standard. So there's a lot of effort went in in terms of the developing the standard. And the IEEE publishes approximately 200 transactions, journals, and magazines. And it sponsors more than 1,600 conferences in 96 countries annually. And now coming to the Circuits and Systems Society, which I am the part of as a Board of Governors member, and also I'm the chair of the this new division, Standards Activity Subdivision. So this division, the charter is to foster technological innovation and excellence in fundamentals, emerging directions, and application of circuits and systems for the benefit of humanity through an interdisciplinary community. So essentially, the key aspect is circuits and systems. So this can encompass like hardware, software, and algorithms. So CAS has a lot of what I would say collaboration with the other societies, such as solid state circuits, given that it is on the as a shared interest in terms of the circuits, and also like has a collaboration with the computer society, because some of the software as well as the algorithms that have a lot of common ground with the computer society. Similarly, again with the signal processing, because most of the signal processing systems have to be implemented in the silicon. The same thing with the ComSoC also. And so that's what we're encouraging, given that the Vizag Bay chapter has already a the ComSoC as well as SPS. It's great to have a CAS chapter also in Vizag Bay area. So as I hinted before, so this is a new division we formed, Standards Activities Subdivision. So this is formed under the Technical Activities Division. So we started efforts to provide core standards for the benefit of industry, including integrated circuit design and test systems, arithmetic, microprocessors, like accelerators such as error correction coding, machine learning, video, and AI. And as I mentioned, this is just a new division that is formed just a few months back. So we have now recruited the several loading members into this division, and now we'll be forming the what we call as standard committees, and then the standard committees will form study groups and working groups. I would explain how this works. I would like to see more what I would say like a participation from both the academic researchers in India, as well as the teaching faculty, as well as the research faculty, and also from the industry in India. So the CAS SASD will be forming 3 committees. One committee is domain-specific accelerators. And if you have attended a recent IEEE event, which I had a chance to give a keynote that was attended close to, I believe, 350 attendees. So that basically had multiple speakers, including me. So that was on the, how do you accelerate a specific workload, such as like machine learning or 5G or error correction and so on. So what we are doing is that we trying to see that, okay, is there a need to develop a standard on any of those aspects? For instance, if you have an accelerator, that accelerator needs to talk with a CPU. Now, how do you define what should be the interface between them? That can be API. So right now, there are so many APIs. Every vendor has a different API. It may make sense to standardize this API so that it's easy to connect the one accelerator with any of the CPUs. Similarly, one CPU can be used with any of the accelerators. So this would increase the interoperability. And similarly, we would like to also develop standards related to microprocessors. So this would be essentially a joint effort with the Microprocessors Standard Committee in Computer Society. And then the new area we are actively looking is the integrated circuit design and testing, the IC design and testing. So interestingly, there is a lot of things that goes into the design flow, such as the timing path optimizations, place and route. These are lot of labor intensive and time consuming. Most of that are like retries, and there's a lot more, I would say, trial and error process. So if you introduce AI into the flow, such as reinforcement learning, you can have a better ROI, return on investment in for the time, as well as you get a better quality in terms of the outcomes. So now the aspect is that each tool has a different interface and a different format for its outputs and inputs. So it makes sense to have some standardization there. And so that given that there is a wide variety of tools, it is important to have these interoperable. So now coming to the how these committees will work. These committees will further have study groups and working groups, and then they recruit more members from the industry and academia. So essentially, you can think about the standard committees as this. The standard committees would have the subject experts. They would help review whether there is a need for a specific topic or not. And when that when there is a need identified by a study group, then the study group will be promoted as a formal working group, and that formal working group is the one that develops the standard. So these groups will have a focus on machine learning and AI, and the key goal is to influence the next generation products. And as you know, there are a lot of moonshot projects in the industry research and development groups. And so if you have some of these standardization, that would actually help these moonshot projects in becoming the high volume products. And the professionals interested in participating, like IEEE CAS SASD activities, such as becoming part of the standard committees, study groups and working groups, they can join this mailing list. We would also share these slides after the talk, so you can subscribe to this mailing list. So while the standards committee needs the experts, so that means only the professionals, the study groups and working groups, there is no bar in terms of who can join. In fact, you don't need to be even an IEEE member to join a study group or a working group. You can be a student, and the key aspect is that if there is a standards working group that is developing the standard on, for instance, like a Wi-Fi, you need to have some subject knowledge in there to really contribute and know what's going on. So this is more suitable, I would say, the study groups and working groups, more suitable for the students who are more interested in terms of the a new technology, and also have the interest in learning more new things. Because sometimes you can join this group and you can follow what's going on, and then at some point of time you may contribute your own proposals as well once you are comfortable with the topics. So we did our first outreach event in Shanghai, China. And one of the reasons we decided to do in Shanghai is that there is a lot of the electronics and the computer development happening in China. And so the China happened to be the second most in terms of the development points after United States. So that necessarily made it that okay, you really have to accommodate the contributions coming from China as well. So this is done as part of the IEEE CAS Forum on Interdisciplinary Research, and this happened on November 14th, and this happened in this particular place. And we hosted Professor Arindam Bose from City University of Hong Kong, as well as these other professors. And we also did a second outreach event in the Bay Area. And as you expected, we didn't do an in-person event because of the COVID-19 here. So we did a virtual event. And we have like budget to do like four more events this year. So we are actually encouraging the one of the Indian like IEEE units to do a in-person event. So now, having explained about the CAS SASD, like I would explain a little bit in terms of the how the IEEE standards process would work. So this slide is a little bit outdated. If you have seen my earlier slide, I was talking about for instance, the like in terms of the 1600 conferences, right? So this 1300 plus is a whole number. And now, if you look in terms of the active standards, we have 1200 active standards, and then we have like I think these numbers are again not the latest ones. So the numbers again you can refer back to my first slide. But the key point I want you to take from this slide is how the IEEE is organized. So the IEEE, it's a member driven. So essentially most of the members are like fall under this division, like members and geographic activities. So if you the chapters are under this division, like MGA division. And now what happens is that you have a section, and section reports to the region, and the region reports to the MGA. And then under each section you have multiple chapters. So this is where you have a lot of local events. So usually the chapters do the more of grassroots activities. They would have like industry speakers from like both the region and national, sometimes international. But it has a more local member focus. It basically looks in terms of the, okay, these are my local members. What is of more interest to my local members? They will try to get those speakers. And then you have a like educational activities division. So these are more in terms of there is an IEEE TV that has several like a kind of tutorial kind of thing. Sometimes like the information shows and so on the IEEE TV. And as well as there are a lot of the IEEE educational content. And then if you are into research, you would be definitely going through these publication activities. And there are a lot of like transactions, journals, and conference proceedings. And then we have technical activities. These are kind of related. So the technical activities, you have different societies. So for instance, Computer Society is the largest society in IEEE that has almost more than 100,000 members. And you have societies like Communication Society, and also the Circuits and Systems Society, which I'm part of. So you have like a lot of these technical societies. Each society has a focus in terms of the the subject area. And most of the time, as you expect, there is a lot of the overlap between these societies as well. And consequently, a lot of members are actually like a lot of members have like joined multiple societies. Myself, I have like my research is necessarily like cross-disciplinary. So I have membership in I think close to 10 different societies. And at the same time, these societies would also collaborate on the several of the conferences as a joint sponsors. And now, if you are looking in terms of this chart, you have. Let me point my laser here, if I can do that. So now in this chart, what I would like to show is that how the society is related in terms of the standard groups. So you have the Standards Association. This is a division within IEEE. And so what it does is that it has here, as you see it, it has 200 plus companies as members. And it also has the individual members. So these members essentially is kind of the people joining the Computer Society and Communication Society. So some of the people who are working in industry, they join a Standards Association. And so, as I said, like you do not need to join IEEE or Standards Association if you are contributing to like the study group or working group. You only need to join the Standards Association if you want to be an officer or if you want to have a voting rights on the standards development. So usually when you're trying to contribute something, it's good to have your membership in the Standards Association also, because you have a voting right. And so now the way this connection works between the societies and SCA are, like each society would sponsor what we call as a working groups or study groups, and these working groups would essentially like develop standards, and these are both reviewed by the society as well by Standards Association. So that's how these are connected. So essentially, if you are trying to develop a standard into, for instance, a computer science related, you would find a standards committee in computer society, and then submit the proposal there saying that I would like to develop a project, and then you would go from there. So I would explain this process a little bit more in the next slides. And the standards board, like in IEEE, has several committees. Like one of the committee you would be seeing more is what you call as a NESCAM. It's a new standards committee. If you want to develop a new standard, you'll be interacting with this committee a lot of times. So in this one, if you see this, there are like 5 stages in developing the standard. The first stage is initiating the project, and the next one is the mobilizing the working group, then drafting the standard, and then balloting the standard, and then getting the final approval. And then once these 5 stages are done, these 5 stages typically take anywhere from like 1 year to 3 years. And the maintaining the standard is typically like the standard is valid for 10 years. So it is a longer time. You have 10 years for keeping the standard active. If there are any errata and so on, you'll be fixing that. And at the same time, you may renew the project or revise the project, and then you can again make revisions. So that's how the Wi-Fi standard is being revised all over, every time. So typically, in the first stage, if a member, like any member, can simply have an idea saying that, okay, I think there is a standardization needed for this topic. That can be, say, for instance, if somebody has an idea in terms of a like interface needed between for instance, a solar cell and any other equipment, they can propose a standard for it. And so it is proposed to a sponsor committee. And so typically you have to develop it's kind of a more formal proposal. So you typically like form a study group to develop this formal proposal, because typically if one person has an idea, he or she won't necessarily jump to develop a formal document immediately, because it is not a good idea. It is not a good process, because you want to get the consensus from the stakeholders to see to get more inputs, and then refine your idea, and then submit that idea. So then this idea, as I said, submitted as a formal document, PAR, like project authorization request. And then once you submit that one, you can initiate this process. Now this would be reviewed by NESCOM. As I said, it's a new standards committee. And then once it is approved, then you can move forward for the actual standards development. So as I said, it's the NESCOM is one of the 6 governance committees. And this consists of 10 to 15 members. And these are also voting members of SA Standards Board. And as I said, the NESCOM has authority on in terms of the PAR. And so one of the things I would like to explain here, right? So you can start this project when there is a need for an idea or a concept to be standardized. This idea or concept can be very broad or can be very specific. As I mentioned, as I hinted in the previous slide, right, no standard can be developed by one person alone, because standards is a consensus process. there are users for the standard. So if you do not find the users to join as the stakeholders in your standards group, that means they're not going to use that standard. So like whatever you start as an effort, that may not materialize. And so essentially this is where you need these standards committees. The standards committee would say that, okay, like if you propose an idea, they would help you to find the stakeholders for you, and then you can develop a what we call as a project authorization request. So these are these standard committees are the ones that can bless your idea and then help you to progress towards a PAR and then a standards draft and eventually a standards document. So as we mentioned before, the CAS SASD, we are forming 3 committees: one committee on accelerators, another committee on processors, another committee on IC design and testing. So if you guys have any ideas in terms of the a concept that you think it does better, it has a potential to be standardized, you can contact me and then I can help put together like a study group. Then you can submit a part to the to the review. And so another aspect is that a standards project doesn't exist until a PAR is approved. So, but you still need to have a mechanism to do to develop this PAR, because PAR is a formal document. You need to have more inputs into that. So you need to have a mechanism to develop this PAR. So what this mechanism is called the study group. So essentially, once you have an idea, you can pull together some of your colleagues, and also you can pull together some of the the stakeholders who can be your potential users, and then you can develop this document. This document is actually 1-page document, sometimes 2 pages, and these groups can exist up to 6 months. And for instance, we did a PAR document recently. I would show that also, but it usually takes a lot of time to agree on specific wording, because this is the scope of the project and what should be developed and what should be part of the standard. So this takes time because there is there are huge stakes involved for the companies. So it takes a lot of discussions to come to an agreement. So as I hinted before, this PAR is a formal document. So a formal document, I mean, like it's a small, structured but highly detailed document that essentially gives the reason why this project needs to exist and what it intends to do. So essentially, this group, many study groups treat the PAR as essentially like a go-ahead permission from IEEE, which in fact it is, because the PAR is as I hinted in this first line, a standards project, a formal working group doesn't exist until a PAR is approved. So once a study group gets an approval from the IEEE SCA, the study group automatically gets promoted to a formal working group. So as we are folks mentioning multiple times, an approved PAR is needed before the official or formal work is begun on a standard project. So it's, as I said, it's a work authorization by IEEE SCA Standards Board, and NESCOM examines PARs and makes recommendations whether this project needs to be pursued or not. An approved PAR is valid for 4 years, and the PAR is deferred also when the standard draft is submitted for RevCom for approval. So RevCom is another committee like NESCOM. This is also under IEEE SCA. So this is the one that reviews the standard and make sure that is following all the IEEE guidelines, and then the approves it. And also, if you're interested in proposing a new standards work, as I hinted before, you can form a study group with the help of a sponsor. And if you yourself have good connections, you can actually form a study group yourself and then approach the sponsoring committees, such as the CAS committees. And then you can work on the PAR, project authorization request and then submit it. So one example is a study group that was recently formed in January 2021, I think roughly 1 year back. And it's sponsored by IEEE Computer Society Microprocessor Standards Committee. It's called MSC. And this is a study group called Additional Floating Point Formats to Support Machine Learning. So in fact, I initiated this study group after realizing that there is a need for this floating point formats for the machine learning, because the floating point formats, the precision and accuracy are not the same as the regular applications. When you look in terms of the specific machine learning workloads. So we had a lot of stakeholders that are interested in. So we have like 32 stakeholders in this one, from companies like Qualcomm, Intel, ARM, and as well as several startup companies. And so we had a series of monthly meetings. So we had like one meeting every month starting in January. And we arrived at a consensus and then submitted a PAR in June 2021. And so this PAR was approved in September 2021 by Standards Board. And so if you see that the study group originally, when I started this one was called Additional Floating Point Formats. So when we included more people in there, what we realized is that, okay, we are not necessarily confining to a floating point format, because there was a professor from Singapore. He had a different the format for arithmetic. It doesn't have a floating point at all. And so essentially we expanded our scope, like for the essentially, instead of simply saying additional floating point, this became a arithmetic format for machine learning. So then once this project gets approved, this gets a number also, like how you got a 802.11n. So this particular one has a name 3109. So this PAR is valid until 2025. So now we became this informal study group became a formal working group. And you can see this like how this group evolved. What are these meeting consensus in this meeting link here. So in this drive link here. So this drive link has the several meeting minutes, as well as the who are the members, as well as the the timeline in terms of what happened. And this particular working group has two co-sponsors at this point of time. Both are from Computer Society. One is CSMSC, that's a Microprocessor Standard Committee. The other one is the AISC. AISC is AI Standards Committee. And then as we said, we formed the CAS Standards Committee, Standards Activities Division recently. So now one of the new CAS standard committees will be forming soon. They will be joining as a co-sponsor to this project also. And I can show this how this document looks like. You can see that we spent more than 6 months to develop this standard. Let me see where I can open this. Sorry for that, give me 1 second here. Hope you can see this screen here. And in this one, if you see this, there is a 2-page document here. So as we said, the study group, we had 32 members. And if you see this one, we have compared to the original study group name, we changed the project title. And then we have who is the sponsor for this one. So we have the the Computer Society MSc, and similarly we have AISC here, that's the AI Standards Committee. And then I would explain this one, the type of ballot individual. So there is two types of ballot. So one is like any person can join the group. Then the other one is entity, like only companies can join. So what the reason we decided individual, so that because we want to have the like academic researchers also join the standards group. That's why we choose this individual ballot. Now, one of the risks is that because there is no restriction on the number of people from any company to join, there is a risk that, okay, some like one company can put a lot of members in the working group, can tilt the standards in its favor. But there are checks and balances, because when we see that people are voting the same way, favoring one company, we will look in terms of the those particular votes. Some of those votes would be invalidated. So there are checks and balances, even if it is an individual ballot. Typically, all the companies work very like in a fair and honest way. So typically, even there are one or two members from each company. In terms of the like when they're like voting, and typically it is not like tilted towards one company. It is more based on the proposal merits. And also most of the time when it comes to the voting, typically there would be only like for instance, one person from the company would be voting rather than multiple people would be voting. Now, if you see this one, we said we are expecting this draft to be by December 2024. And we are in 2022, and then we are saying that even to do a draft, we are expecting 2024. As you understand, this is a high stakes game. So there is a lot of crucial aspects in terms of the what I would say, like impact on the products. So companies are very careful in terms of the committing to a particular the proposal for the standards. So there will be a lot of back and forth in terms of what goes into the standard. Even as I mentioned, just to define like what should be the scope of the proposed standard, we have to have like the up to 6 meetings. So this is not a a simple process. The standard process is a pretty complex process. But at the same time, if you are involved in the standard process, it gives you in terms of a very good idea in terms of how the technologies are developed, and also it gives a very good understanding of the industry processes. For instance, here we're defining the proposed standard, the scope. We are saying it's a binary arithmetic and data format for machine learning optimized domains. And then we are saying that it specifies the default handling of exceptions that are happening in this arithmetic. And then we are saying that this is providing a consistent and flexible framework that is more suitable for machine learning systems, both in hardware and our software. And also the key aspect is the interoperable. And also we had already one standard for floating point, IEEE standard 754. Most of you might know this one because this is the standard that all your computers are designed to work with. Like if you take any floating point arithmetic in any of the processor that you have in your mobile phone, on your laptop, they are designed to work with IEEE standard 754. So what we are saying is that while we recognize that you need a different arithmetic for machine learning, we're trying to align this new standard with the 754 as much as possible. And then we are saying is that what is the need for this project? So the reason is simple. These MLS, like machine learning systems, have different arithmetic requirements compared with any other domains. And the precisions are lower, and accuracy is measured in dimensions than just numerical. Like what it means is that typically when we are talking about arithmetic accuracy, you would say that, okay, I need a 32-bit floating point or 64-bit floating point arithmetic. But typically for machine learning, it is not so much about it. It's more about, okay, if I'm using a 8-bit integer, I can get the same inference accuracy as a 32-bit floating point. So then there is no need to burn all your computing power on doing a 32-bit floating point. Since the inference accuracy is the same, so my results are not not different, even if I use a full arithmetic, full precision arithmetic. And then the next aspect is that the machine learning systems are also part of the like mission critical and safety critical systems. So if there are no standards, because if there an exception happens in arithmetic, then like each of these systems would act differently. So then you have no idea in terms of the what's happening, because depending on which vendor made this one, you don't know whether the system is going to fail in this condition or a different condition. So that's why you need a standard there. And we are saying is that if these systems are built with inconsistent expectations, they would essentially like they won't have the compatibility, and also essentially we can't reuse these like hardware and software and as well as the training data for these machine learning systems. So this is how we said that this is the need of the project. And then we said, okay, who are the stakeholders for the standard? So you have to identify this also. So essentially for any machine learning systems, it's kind of actually very broad, because now machine learning systems are very broad and they're used all across the different domains. So it's pretty much under the earth, pretty much under the sky, you could say, right? So this one is we put it as a system developers, vendors, and users of machine learning applications across many industries and interests. And then we said we identified some of them, like the telecom, e-commerce, fleet management, automotive, robotics, and security. And then the broad and the medical, and then the broader the core domains of compute and storage. And so essentially, right, pretty much the stakeholder for this standard is any computing and storage vendor who is making the hardware or software products. And similarly, any application company such as telecom, e-commerce company, or any of these companies we listed here. And then next one is that we have to declare these ones, whether you need any copyright permission for this project. So at this time, then the answer is no. And then do you need any registration activities? So at this time, it is no. And then the other question is that are there any other similar standards? So as we said, right, we are trying to align this project with 754, but at the same time we don't know whether we are going to take the route of 754, because we may completely do a different arithmetic format. So at this point of time, there is no like a similar standard to what we are trying to do. So the answer is no at this point of time. So if it happens that this new project, instead of going in a completely different route, if you go in terms of for instance, a 12-bit floating point, but with a similar kind of rules as the 754, but with more features like what I call as a block floating point. The block floating point is that several numbers would share the same exponent. So typically, if you're aware of the floating point number, it has a mantissa and exponent. So now in the block floating point, because of in a matrix, the numbers in a row, they can share the same exponent because all the numbers have a similar precision and accuracy requirements. So then you can save the cost of that exponent. So instead of doing the computations on, let's say, 128 different numbers, you just need to do on one number if your block is 128 numbers. So there are more advantages in terms of the block floating point. And so in fact, we used this block floating point long time back in different applications. So this is also now quite relevant for machine learning. So that is one proposal that would be coming up for this one. But again, like until all the companies would agree to that, there is no assurance that will be selected. It could be a different like arithmetic format. As I mentioned, there's one professor from Singapore is proposing that does completely away with the floating point. but it still has a dynamic precision and accuracy. And now the other aspect is that you can develop a standard with other organizations such as ISO or any other standard setting one. And so at this point of time, the intent is no, so that's why we included no here. Now, if you see this one, it's pretty much like a one-page document. And once you identify sponsors, the key aspect is that you're identifying the 5.1 to all the way to the 5.6. And the key aspects that need a lot of discussion are the 5.2 and 5.5, like why the project is needed and what is the scope of the proposed standard. Because each of these stakeholders have a different idea in terms of what should be the scope of this. As I said, when I started this study group, my impression is that, okay, we should do a block floating point as part of the standard, because I did block floating point long time back for different application. So I thought that would be useful for machine learning also. But then some more people came in and then they said that, oh, okay, actually you don't need to do floating point, we can do something else. So it all depends on the stakeholders. So that's why the scope became not just floating point, it became like arithmetic. Instead of simply constraining yourself to a floating point, when you say arithmetic, it can include a like integer arithmetic, floating point. It can include the like this dynamic arithmetic without any floating point. So let me get back to my presentation slides here. And as I mentioned, that you can also follow this progress in the of this group by following this link. So this link would include the stakeholders as well as the meeting minutes. So you can see how the discussions happen. Okay. So how I'm doing with the time, Mr. Murthy or Mr. Satish?
Yes, sir. We have 5 more minutes of time, sir.
5 more minutes. Okay.
And then we dedicate 5 minutes for discussion. Like there are a few questions from the audience.
Okay, sure.
Okay. At the end, we will take up, sir.
Okay, sure then. Yeah.
Yes.
So now let's look in terms of the types and nature of projects. And you can have a standard that contains the mandatory requirements, and you can have a recommended practice. So in a sense, you can say that, okay, this is how it has to be done. That's one way to do the project. The other project can be, you can simply say that, okay, this is what we recommend. So it's not a mandatory, but it's more of a recommended one. Or other one is just a list of suggestions. Sometimes you can have like even the define a standard for abbreviations also or symbols also. And also you can have the revisions of existing standards. And sometimes you can have the like a project for fixing the any mistakes or any amendments that are needed. And as I said, you can develop standard for any topic, right? One list of terms, definitions, or symbols, but these are related to any field of science or technology within the scope of IEEE. And similarly, you can develop any of the lab-related ones also for devices, equipment, and systems. And as I mentioned, you can do in terms of the recommendations for for any of the state of the art in terms of the any technology that is within the scope of IEEE. And the key aspect is that if you have an idea, you need to find a standards committee that sponsors your idea. So there are 42 technical societies, and depending on your idea, you can find which society is more relevant for you. As I mentioned, I'm part of the CAS, and so if you have any ideas related to circuits, systems, as well as any hardware or software or algorithms, you can approach me, and we can do a study group on any of the topics that you're proposing. And as I mentioned, there will be 3 committees that will be formed on this. And again, this mailing list we're including at multiple slides, but you can join this mailing list to know what's going on with these committees. And as I mentioned, once the PAR is approved, the study group becomes a working group. And let me skip these like details here. These are more in terms of the like once these kind of committees are formed, they have to follow a very strict procedure in terms of the making sure that there is a transparency as well as a like fair handling of all the issues when developing a standard are followed. And let me skip on these ones. And I think I explained the balloting process before. So there will be an individual versus a corporate one. So most of the standards we're doing right now are individual based. And so typically another thing is that once what happens to the standard after approval. So as you know, it's an IEEE, it gets published. So most of these standards, if we can buy it from IEEE, most of the people who are using standards, they buy it from the IEEE Explore, or like there is an IEEE separate website for selling the standards. And so this is the link where you can find the different standards. And as I said, if the standards have errors, it's not desirable, but it happens. Because as I said, it's a very complex topic and it's a completely like a technical jargon. Even though there are professional editors from IEEE, unfortunately, they don't know all the technology. And so there will be some errors that would creep in. And then these errors can be fixed by issuing an addendum or like an errata sheet. And you can do minor revisions by doing amendments. And as I said, because the validity period is 10 years. So what is the call for action? So there are several ways you can be involved in these standards. You can become a member of a study group to propose a new idea, so that you can do a project authorization request. And then you can be a member of working group to develop a new standard. And as I said, anyone can join. Like you can be like an IEEE member, or you don't need to be an IEEE member also. But if you are an IEEE member, then like you can vote as well as you can hold officer positions. And also you can be a member of standards committee to review and oversee the work of working groups. So for this one, typically we would like the experts to join the standard committees. And then you can be a voting member of IEEE CAS SASD. So this is through nomination. So for this one, you need to be both IEEE and IEEE CAS member. And now, if your company is already a corporate member, you don't need to get a IEEE SA membership, because since your company is already a corporate member, you get that membership automatically. And so as I said, this link, I'm giving this again. And for further questions, right, if you can connect me through LinkedIn, and then you can email me through LinkedIn or message me on LinkedIn. So that way, if you're interested in like participating in any of the activities, I can connect you with the right people. Similarly, if you have an idea to propose for a standard, then we can form a study group, and then we can take to the next level. So I think with this, I'm done, and I'm open for the questions.
Thank you, sir. Really, it's very interesting discussion today. Interesting lecture today. So, sir, there are a few questions from my colleagues. So, first of all, I have one, sir. Let me first start with mine. This IEEE, I'm a member of this working group of IEEE Standards Association, IEEE P2520 series of standards on olfaction devices and systems. So, of course, just while a year ago, I was very much interested to contribute something to the IEEE beyond the section. While I was, because I am a senior member, I tried my level best to search through the entire IEEE Explore, IEEE website, and found this particular opportunity. Then quickly I spoke to that Ehsan Danish, and he adopted me into this. So in that way I got into this, but I could not contribute much in specific to this olfaction devices, because that's specific to sensing smell, that device. And on the other side, though I could not contribute, but I could learn a lot, because they have organized nearly 5 technical talks In about 12 meetings in that year, there were about 5 technical talks, and they were very good. Which two were research, two were from academics and research resources, and 3 are straight away from the industry background. So this is what my experience that I have being a working group member. But similarly, the other people, they are asking is what is the exact difference between a study group and a working group. And being an academician, teaching core electrical and electronics engineering concepts to the students, and doing research in a particular field, specific to a particular field. uh, what do you suggest? Do we have to get into this study group SG or WG? Which one would be more apt to us?
Okay. That's a great question. I think first of all, I think it's great that you joined a working group. I think it's a great, I would say, great initiative from you. I think to explain the difference between study group and working group, as I mentioned in my slides. So once the project request from the study group gets approved, then the study group automatically becomes a formal working group. So essentially, the progression of study group uh, is the working group. And so the working group is the one that can actually develop a standard. So study group is more like a informal working group. You can consider that way. And once the PAR is approved, the project authorization request is approved, then the study group graduates to a working group. And now to answer the question that what is the need to join a working group or a study group, right? So I think I can probably share the members in one of the study group I initiated that became a working group. So we had more than 50% of them are from academia and 50% from industry. So usually, right, because having academia, especially, right, would bring some balance, because you would also look into different all different aspects. And now typically most of the people who join from academia are the people who are actually doing the research in that field. So because they are actively publishing, and then, for instance, as I mentioned, in the working group which I am the chair, we have a professor from Singapore. He has his own proposal for the arithmetic for machine learning. So it's his vested interest to present his work and then to present this proposal, because if he's active in the working group, he can present his work better than anybody else. So that's one advantage, because a lot of times there is a lot of prestige. If your proposal gets accepted as an IEEE standard, that's a lot of worldwide recognition. So essentially, the point is that, right, if you are doing some research, right, it's great if you can your research proposal becomes part of a standards proposal. That's a very great a wonderful recognition for your work, because getting published in a conference is one thing. Getting part of a standard that becomes a product is a different one. And then the other aspect is that if you're only teaching, and let's say you're not doing any research, you're not publishing, but if you're only doing teaching, it would be still relevant for you to see what's happening in the field. What are the the different state of the art approaches to solve a problem. So this essentially participating in a standards group will give you an easy way to understand what's going on in a particular field without reading a lot of papers, in one sense, because you'd see a lot of interaction from the industry people. They know what they're doing, and at the same time you would see a lot of the people from academia who are publishing a lot of papers. There you would see that, okay, which papers are actually have more impact, because those are the ones that are being incorporated into a standard, which essentially becomes part of products at a later point of time.
Yes, sir. So suitably the academicians are eligible for both. I mean, it completely depends upon their research field of interest and the time that they can invest. And all these things put together, it is completely, it is at the discretion of the academician or the person who is interested, right?
Exactly, exactly. I would add one more thing for students who are doing some kind of a thesis project or any of the engineering projects. It's a good idea to be involved in these kind of groups. And the reason is that there are a lot of the studies have to be. I think there's some background noise coming from.
So here,
So
no noise from here.
okay, okay. So I think that might be okay. So what I'm saying is that there will be a lot of small engineering projects that have to be done to decide which proposal has to be taken. And for that one, if you are a student, right, and you're taking some active role in performing that work, you get also a lot of recognition from the people working in industry and academia. So that would have a lot of advantage for you because you get recognized that okay, you can do this task very well given a project requirement. To give a clarification, when you are developing a standard, there are a lot of simulations have to be done, and you can propose to the group saying that okay, I can do this benchmarking study to compare these different proposals. So that essentially is a very good project on your resume. So for students, it would be a great opportunity.
Yes, sir. Thank you very much, sir. And sir, the other question, it is a little too much general. It is like out of the box question. So it is out of interest from some of the participants. What they would like to know is how did you get this idea of coming up with a new standards in specific to this particular society? Because the basic idea behind asking this question would be like, no, the people, they don't want to be like an electricians who work on the end devices, but rather they want to think like an electrical engineers who would work on the principles. So they want to read the mind actually. They want to know how could you pick up such an idea of starting a new division in specific to CAS. We have a standards association which is working on several other things, but usually we are adapted to work in a particular group, but it is not like floating a new group, floating a new
Yeah,
division.
I think I could clarify that. First of all, there are 42 technical societies in IEEE. So I think most of them, except I think 4 or 5 societies, have no standards related subdivisions or the boards. So what we got is that the IEEE said that okay, they're going to give funding for 2 years if the society which don't have any standards activities started a division or a subdivision. So that's what we kind of started. It's not like just my idea. It is more in terms of we got an email from IEEE saying that okay, your society doesn't have any standards activities. So if you form a standards activity subdivision or the standards activities board, we would support that board with the initial funding. So that's one of the motivation. Because and also when we are looking in terms of the other aspect, I could explain is that the computer society has 100,000 members, and circuits and systems has 10,000 members, and IEEE has more than 420,000 members. So I'm giving some stats here. More than 50% of IEEE members belong to one or more societies. So that means 210,000 members belong to one or more societies. And if you see computer society has almost like 50% of that, right? Like 100,000 members. So most of the standards activities, given the huge presence of members there, are driven by computer society. So even the 2 standards I was involved in, they're developed under the computer society. And so given that there is a lot of membership there, that's why the typical home for all the standards, even though that is for instance, we are developing standards related to microprocessors under computer society, even though that would have been at circuits and systems before. So now given that there is this kind of a balance is not there, we said, okay, it's good to have standards like board within the circuits and systems society also. That's why we started as a standards activities board within the CAS. Just the nomenclature we had to change as a standards activities subdivision, because on the CAS everything is called divisions and subdivisions. So that's what we have to change the name that way. But essentially the point is that it's not out of normal for each society to have a board or division related to the standards. So CAS standards activity subdivision is such one unit.
Yes, sir. Thank you very much, sir. This is really good information to all the chapter chairs, in fact. Maybe. Yeah, yeah. And, sir, one last question. Is there any validity to the standards that you propose finally after balloting and all these things come out as a outcome of?
Yes. Yeah. Typically, these standards would be published in IEEE, and the standards usually when the standards get ratified, the companies would start using it in the products. So that's where you have the lot of the validity and the importance for these standards.
Actually, they want to know, is there any expiry, like to particular duration, because the particular patent,
Yes, yeah. Patents have validity for 20 years, right? The standard typically has like 10 years, as I showed in the slides.
yeah.
And now you can revise the standard again and then make it active for 10 more years. So in a sense, you can make it as an active standard all the time. And even sometimes, let's say you design a standard and 754 is being revised recently, and then it will be revised again 10 more years later. So as long as people are using floating point arithmetic, the 754 would be there. So it's not. So what I'm saying is, even though it's a 10-year one, you can always revise it to make it active.
That's all, sir. Thank you very much, sir, for sharing a lot of information related to this CAS activities as well as your subdivision. And sir, TSN Murthy garu, do you like to add something? You can unmute, sir. Sir, you are not audible. Yeah. Murthy, sir. I think still you are not audible.
Yeah, am I audible, sir? Am I audible?
Yes.
Sir, Kiran garu, thank you very much, sir, for your constant support and encouragement for all these activities. Definitely, every time we asked you, immediately accepted our request. Definitely, we are also expecting same kind of support for future events. Yeah, thank you very much, sir. Thank you very much, sir.
Definitely, Murthy. And again, thank you, Mr. Chaudhary and Mr. Satish, and thank you, Mr. Raghu garu.
Sir, one more thing, Kiran garu. He is the Samir Chakravarti, who is the vice chair of our ComSoc. So yeah, but he log in through Chaudhary PSR.
Oh, okay.
His name is Samir Chakravarti. Yeah. Not only he is not only involved in the ComSoc, and also he is a very active in his section wise. So he's supporting a lot. Yeah.
Thank you so much, Mr. Samir. Sorry for that mix.
No problem, sir. So now I request Akash to give a vote of thanks.
Yes, sir.
Yeah.
Am I audible, sir?
Yeah, you are audible.
So I would like to thank Dr. Kiran Gunnam garu, who enlightened us with the various initiatives of IEEE standards and IEEE CAS and pair application, and going through the documentation also. And I will take this opportunity to thank Chair IC3P, Dr. PSR Chaudhary, Vice Principal of RIT, and General Chair for IC3P, Dr. SLN Sri Lakshmi Narayan Garu, and Chairman of the Raghu Educational Institutions, Raghu Kalidindi Garu, and Director of REI, Dr. Rahul Verma Garu, and Secretary Srimati Ramadevi Garu to providing this platform and smooth organization of the IC3P. And I will extend my thanks to TPC committee, Dr. WSSS Samir Chakravarti Garu, Dean R&D, Raghu Institute of Technology, and Dr. TSN Murthy Garu, the Chair, IEEE ComSoc, Vizag Bay section, for extending the smooth organization of these proceedings and the conferences. And I would like to extend my thanks to faculty volunteers and IEEE student branch volunteers for live streaming of these proceedings and the conference. Thank you, sir. Thank you all.
Yeah, thank you, sir. And at last, I would like to once again thank TSN Murthy Garu for connecting our PSR Chaudhary Garu with Kiran Garu. And this has become a very strong association and going to be much more stronger, because my chairman and as well as my vice principal Chaudhary Garu both have gone through the biography as well as his activities, and he being a world renowned person in this particular technology. So there was really some kind of interest from the chairman as well as my vice principal to associate more stronger with Dr. Kiran Garu. Though we are connected with him during that seasonal school, for these people it is new, but once they came to know that he is also from Andhra Pradesh, and he is also done his UG here, and they are very well impressed, and giving something back to the society and to the native place of Andhra Pradesh is much more impressive. So this is a message from my chairman as well as my vice principal, sir. So I just wanted to convey it to you.
Sir, Chakravarti garu, I would like to add one point. So, sir is committed to promote research, and he is also coming forward to encourage some research kind of thing for students as well as the faculty. Only thing is we have to ask him, and we have to utilize the opportunity.
Yeah.
Sir, sir. So thank you very much,
Yeah,
sir.
I think
Kiran, sir.
definitely there's a lot of potential in our area, right? Because there is a lot of students who are interested in doing new projects. I think we should really encourage them towards that.
Yeah.
Definitely, sir. We will do it. Thank you very much, sir. Thank you.
Yeah.
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 Thank you all again. Thank you so much. It's a
Thank
pleasure
you.
for me to talk in this one. Thank you so much.
Thank you very much, sir.
Thank you.
So we'll be in touch with you, and especially the student branch. An year ago, we used to have a caste society student chapter here in the campus, in the student branch. However, in the last year we could not do much, but this year definitely we are going to rejuvenate it, and we are going to definitely do good number of activities under the caste
Yeah, I
society.
hope you could start a CAS branch. I was encouraging Mr. Murthy for a long
Yes,
time.
sir. Yeah.
And
Sir is
also, we
telling.
have a lot of funding also, because if you are forming a new chapter, we have funding, I believe, up to $5,000. So it's a significant funding to do an event, an in-person event. So again, we can talk offline, Mr. Murthy, but I'm hoping that you could get this
Definitely, sir.
started.
Definitely, we discussed Samir and Satish Garu. So definitely, we will start the CAST chapter in Andhra IEEE Vizag Bay section in near future, sir. So,
We'll take this word to the chair IEEE also, sir.
Okay,
IEEE.
that would be great.
thank you, sir. Thank you.
Okay, thank you all. Thank you for this opportunity again. Thank you so much.
Thank you, sir. Thank you.
Thank you,
Thank
sir.
you again. Thank you.
With your permission, I'll end the meeting, sir.
Yes, yeah.
Yeah. Thank you, sir. So all the participants are requested to join the respective sessions for paper presentations if you have any things scheduled for this today, for today. And again, we'll be meeting after the paper presentations at 1 o'clock for an invited talk, which is on nature-inspired techniques for clustering, which is going to be much more interesting. And following the invited talk, at 2 o'clock itself for 15 minutes, we have a formal valedictory function, and we'll be closing the conference to close the proceedings of this conference. So I request everyone to join at 1 o'clock once again for the invited talk following the valedictory function. Thank you, one and all. I'm ending the meeting. Once again, thanks for your support. Bye bye. Sir, good afternoon, sir.
Good afternoon, the organizers.
Yes, sir, this is Dr. Samir Chakravarti.
Namaste, namaste.
Namaste, sir. After a very long time, we are meeting once again.
Yes, yes, yes.
Last time I have seen you somewhere around 2000, 14, 15 when you visited GMRIT.
Yeah, it was long back,
Long
not
back.
14, 15, but it was, I think, 2009. So
Uh,
long back.
I came to you for a winter school, first winter school in
Yes, yes,
I,
yes. That we did organize at 2010, I think.
yeah,
10 or 11. Yes.
yeah,
IIT Bhubaneswar.
yeah, I do.
Yes.
Sir, so we'll wait for 10 minutes, sir,
Yeah,
because,
yeah.
yeah,
Let people join.
yes, sir. So it is like this is an invited talk, and this is quickly followed by a validatory function, just which is a crisp meeting for 15 minutes, not more than that, where
Okay.
the chair of IEEE Vizag based section would be joining, and both the principals of my two colleges, that is Raghu Institute of Technology, Raghu Engineering College, they would be
Mm,
joining, as well as the program chair. Anyhow, he is there.
mm,
He has already joined, so he will
mm.
be available. PSR Chaudhary Garu.
Yeah.
So I'll give you all the
So the
details.
entire conference went online or offline?
It's in a hybrid mode, sir.
Ah,
Actually, we should say that there are 9 sessions, out of which only 2 are offline sessions.
okay.
And those 2 offline sessions, the participants are from my college only,
Okay.
both the
Yeah.
colleges.
Mm-hmm.
And of course, but the inaugural function went well, sir. The local state government authorities, they have visited the campus, and they have actively participated in the inaugural function.
Mm-hmm.
And
So
changed it.
inauguration went offline.
Yes, sir. Only inauguration went offline.
Okay.
The local, this Vizag-based section also stays in the same city, Vishakhapatnam. So he has
Nice.
also graced the function, and my
Mm-hmm.
chairman was there and the program chair. Only 4 people. So
Mm-hmm.
somehow we managed to do it offline. We wished actually to do it offline completely, but the things gone little more serious as we are approaching the dates. That was
Mm.
really tough call that we have taken.
Yeah, here also situations are not good.
Hmm.
Means the COVID situations are pretty bad going on.
Yes, yes,
Cases are increasing like anything.
yes, sir.
Yeah.
So we are, I mean, night curfew is enforced, sir, now, and there
Mm.
are several restrictions on gatherings. And
Mm.
now we are going for a vacation immediate to this conference around tomorrow. We
Mm-hmm.
will be coming back again to the college on next month, the other Monday.
Mm.
We complete 1 week holidays for a local festival here.
Mm-hmm.
And after that, we are not sure whether really we are going to do an offline classwork or not.
Yeah, yeah, that
So
is
we are getting all the things again ready to start over with the online sessions.
true.
uh,
Yes, true.
yeah, yes, sir. So it seems very cold over there.
Yeah, means it is pretty cold. Means we are facing 3 to 4 degree.
Wow.
Yeah. And for last 4 days there is complete rain.
Oh,
We have not seen sun for last 1 week or so.
oh,
Cold and plus rain. So horrible weather. Today morning also it was raining like anything.
oh. So great. So yeah, yeah. The things. It's a seashore, sir. I think you have visited once.
Yes, yes, I have visited. There the weather becomes good normally.
Yeah, yes, sir. So probably this year we'll have some other event, so that we will have a reason to call you, and you will be having a reason to visit visit the campus once again. And it's like after a very long time we'll be associating with you. So we wish
So,
definitely.
also, if this pandemic situation would not be there, there are a lot of events also we organize at
Yeah,
MNIT Jaipur, and Pink City Jaipur is a famous destination for all people for holidays, and all it is a pink city.
yes,
So you people also can come and participate. But
yeah,
once pandemic situations come down, then only.
yeah, sure,
Mm.
sure, sir. Definitely
Other
we'll do
till
that.
that time, every conference, FDP, everything we are organizing only online.
Online, yes, sir.
Yes.
Sir, we shall wait for 8 more minutes, sir, and then we'll start.
Sure, sure, no problem. The
Yeah.
people should join, and then we can.
Yeah, people will be joining limited in the Google Meet, sir. We have shared the YouTube link and we have provided the online streaming on our college
Okay, on
website.
YouTube they will be
Yeah,
looking at
all
it.
the students, because there are 215 number and the Google Meet and all, it would be little disturbance for us to manage
Hmm,
the
hmm,
things
hmm,
and
hmm, hmm,
unnecessarily eating away the bandwidth. That's the reason why we
hmm,
have our own website where we are streaming this
hmm.
directly, as well as we are also streaming on YouTube. Both we are doing.
That is nice.
Yeah, because both college put together, there are good number of participants, like
Hmm,
audience.
hmm,
So the faculty members and the participants itself is crossing 200,
hmm.
and the
Yeah.
student members of IEEE student
Hmm,
branches, they are about 220.
hmm, hmm,
That's the
hmm.
reason why we have actually projected in the auditorium also. We have a small
Hmm,
auditorium and two laboratories.
hmm.
We have a big screen. We are projecting the YouTube link on it,
Oh, that's nice.
so that everybody can enjoy it.
Hmm.
Yeah, and this particular talk definitely going to be very much useful to all the BTech students. In fact,
Yeah,
uh,
I will try to make it
yeah,
simple for them.
we have both CSC people and ECE people, sir, both.
Okay.
So
Hmm.
it's really a good opportunity to both CSC
Hmm.
as well as ECE. And we
Yes.
have a machine learning and artificial intelligence branch in our CSC department.
Oh, nice that you have started
Yeah, we
recently.
have started. This is the second year. They are in second year now.
And that branch will attract more student.
Yeah, yes, sir. And almost 60 to more than 60 students are IEEE student branch members.
Hmm.
So,
Nice.
yeah. So we shall wait for 5 more minutes, sir. I will I'll get back to you.
Sure, sure, sure.
Thank
Thank
you.
you.
Thank you. Good afternoon, sir. Yeah.
Good afternoon.
Good afternoon.
Namaste.
Yeah. Sir, thank you very much for giving your consent and joining with us for the validatory function, sir. But before the validatory function, we have scheduled your invited talk. Definitely, this is going to be very much valuable to all the participants, especially the UGPG students from both the disciplines, because always we know that your talk is interdisciplinary. It even covers both CSC topics as well as ECE topics. So this would be definitely useful to both. And now for this invited talk with me, I have my HOD and Vice Principal of the Raghu Institute of Technology, Professor P. Satish Ram Chaudhary Garu. Along with him, we also have the principals of both the engineering colleges, Raghu Institute of Professor S. Satyanarayan Garu, Principal Raghu Institute of Technology, and Professor C.H. Srinivasu, Principal Raghu Engineering College. And along with us, we also have people from IEEE Vizag based section. Especially, we are glad to have the chair of IEEE Vizag based section, Professor S. Lakshmi Narayan Garu. Along with him, we also have the SEC members who have joined with us. So this invited talk is scheduled as a part of day 2 program before the validatory function of international IEEE International Conference on Computing, Communication and Power Technology. This conference is organized by Raghu Institute of Technology, Autonomous, and Raghu Engineering College, Autonomous. Both the engineering colleges are under the Society of Raghu Educational Institutions, and it is led by the most famous teacher, Sri Raghu Kalidindi Garu, and considering his support, taking his support only, we could do all this international conference. And this is the third international conference in the series, sir. Earlier we have organized two with Springer as a publishing partner, and this is IEEE this time. So this IEEE is a little different experience for us. However, we are very much associated with IEEE for the past 4 to 5 years, especially through the student branch, and we are directly connected to the section activities. So that is what, and we are also delighted to see that you are also a senior member and you are also active in IEEE activities. So that makes the things very, very much apt and in sync with the theme of our conference, sir. So now I request Akash. Yeah. Yeah, Akash, can you unmute yourself?
Sir, am I audible, sir?
Yeah, you are audible. You are audible. Please introduce the other. Please introduce the speaker to the audience.
So, good afternoon, all the participants, and good noon to Dr. Satya Sai Jagannath Nanda, sir. So, I am privileged to introduce our invited talk guest, Dr. Satya Sai Jagannath Nanda, is senior member IEEE, working as an assistant professor in Department of Electronics and Communication Engineering of over 10 crores. Thank you, sir.
Yeah, thank you very much, Akash. Sir, now we can start over the session, sir. Over to you. You have the
Thank
privileges
you.
to share the screen.
Yeah, thank you,
Sir, you are muted.
the chair. Can you able to listen me?
Yes, sir, you are audible, sir.
Yeah. Yes, sir. Thank you very much, sir. Now
Thank you,
over to you,
Samir
sir.
sir and Akash, for a warm welcome to the conference. So let me share the screen. So I believe my screen, audio and video all are visible to you.
Yes, sir. Visible, sir.
So today we are going to discuss a very important topic of data clustering and how the nature inspired algorithms are applied for enhancing its performance. So on this particular topic, I have been working from last 1 decade, and we have collectively done a workshop in which the program chair, Dr. Shamir Chakrabarti, has also joined. So on the similar aspect, we have been working from last 10 years. So data clustering is a problem of grouping identical things. If you observe here, our objective is to group similar kind of items together. On the left side, you can observe 3 flowers are there. Okay, 3 different type of flower are there. Okay, here we have to consider that we will design a robot that will identify these 3 kind of flowers. That is the problem. Okay, and from each of the flower there are 50 pieces are there. So from 3 flowers there are total 150 pieces are there. So 150 flowers, they are in a bunch, and our objective is to segregate all these 3 flowers, means keep these flowers in 3 different buckets. Very simple problem. 150 flowers, 50 from Setosa, 50 from versicolor and 50 from Versinica are given, and we have to separate these 3 flowers. Okay. So how the robot will know that which flower is which one? So it will first take each of the flower and measure its sepal length, sepal width, petal length and petal width. 4 things it will measure. Okay, and once the thing are measured for each of the flower, then we have plotted these things: sepal length, sepal width and petal length. Obviously we can show maximum 3 dimension, so the 3-dimensional plot has been shown for this. In this, each point is representing a flower. Okay, so now we have tried to put all the flowers together. Then you can observe that once I have applied a clustering algorithm and try to segregate these flowers or try to find out these flowers, then you can observe that this entire set has been bifurcated into 3 different groups. One is this pink color one. Hope you can able to observe that I am highlighting with red color marker. This pink one, this black one, another group, and this red one is another group. Okay, so 3 different groups it has made. Okay. So the beauty of the thing is, when we applied the algorithm, this has made it into 3 different groups. So what is the important thing to notice over here? That the pink flowers, they got completely separated. There is no overlapping of points. They are completely isolated. Whereas this black points and red points, they are overlapping with each other. They are sandwiched on each other. Okay. So why it happens? Because this flower, Setosa flower, top flower you observe, it looks completely different. Whereas this versicolor and versinica, these 2 flowers look alike. Okay. When things look alike, it is very difficult to segregate them or separate them. Identical twin brothers, sisters, very difficult to distinguish them. So when things look similar, it is difficult to separate them. So that's why these black points, which are obtained from the versicolor flower, and these red points which I have obtained from the Versinica flower, they are overlapped with each other. So when these things get overlapped, how we will separate them? That is a very important aspect of clustering. So mathematically, this particular problem is defined as a data set which has 150 points, n is equal to 150, and we are trying to group it into 3 different groups. We will make the group such a way that in every group there must be some of the flower. Okay, in the first group there will be some 5-10 flower. In second group there will be some 5-10 flower. None of the groups should have empty. Means there should be at least some flowers will be there in each of the group. Then among different groups there should not be any common element. Okay, interdisciplinary things between 2 different groups should be 5. That means a flower has to be any one of the 3. It cannot be 1 and 2 both. Okay. Now the third thing it is saying that if we have 3 different flowers and 150 pieces, then we have segregated them into 3 buckets. Okay. Then the summation of all the flowers of the 3 buckets is equal to 150. That means in first bucket, if we have taken 40 flowers, in the second bucket, if it is 50, then the third one should have at least 60. So that is as simple as that. So how we will do this particular clustering? The clustering is mostly done by minimizing a Euclidean distance function. That means from every point to this particular clusters, we try to minimize the distance, and thereby we have formulated it as a optimization point, optimization task. That means from every data point to the cluster centers, we will try to find out minimization of distance. What is Euclidean distance? That is, we know that between 2 points, how we find out the distance? From our +2 mathematics, we know that between 2 points, distance is x1 minus x2 square plus y1 minus y2 square, and take whole root over. That will give you distance. So if you will minimize the distance between the points and try to make them group, then it is a very effective solution. Based upon that, a very popular algorithm, K-means clustering algorithm, is proposed by Lloyd from Bell Laboratory. Bell Laboratory in USA is very popular because that laboratory has given research community a lot of algorithms, a lot of innovations. So everybody must have heard about the Bell Laboratory. So this K-means algorithm is also invented by Lloyd from Bell Laboratory. Now, besides this Euclidean distance I explained you, there are many other distances that can also be used for the clustering purpose, like midway distance, centroid distance, intra and intra-cluster distance, Dunes index, David Burden index, CS measure. These are mathematical terms. In these mathematical terms, if we minimize or maximize, then we will get those clusters or those groups. These are the scientists who have already used these functions to do the clustering task. So I have highlighted all the scientists who have used these particular mathematical functions to achieve those cluster groupings. Okay. So this we understand that this has been formulated as this clustering or grouping task has been formulated as a optimization problem. So how we will optimize a particular thing? Based upon that, this problem has been formulated. So when you do an optimization, the optimization is solved by many ways. One of the very popular ways from our +2 mathematics, we know that the maximization or minimization on a particular curve. How you will find it out? That how to find out maxima on a particular curve? That everybody know that you always take the derivative. Derivative represents the slope of the curve. So you go on taking the derivative. So this is a simple curve. On this particular curve, from the left side, we go on taking the derivative until and unless we reach to this particular maximum point. Okay. And here derivative represents the slope of the curve. So when there is change in slope, either from positive to negative or from negative to positive, then we say that there exists a maxima over that point. Okay. To ensure whether that is a maxima or that is a minima, we take double derivative. Okay. But in case of a multimodal problem, means there are more than one maxima. Okay. Here in this particular problem, there are 3 maximas are there. So when we apply this derivative based algorithm, go on taking the derivative from left or right, then we will reach at these maximas. No doubt they are the maximas, but they are not this global maxima. That means they are not the highest peak. They are the local peak, but they are not the highest peak. This is the highest peak. So our objective is to find out this highest peak. So how we will solve this particular one? That the derivative based algorithm, they fail because they get stuck at these particular points. So another example I am showing you. You see this is a 3-dimensional plot. In this there are 3 peaks. One peak here, another peak here, another peak here. 3 peaks and 2 minima. One minima is here, another minima is here. So this 3-dimensional plot, if we will show in 2 dimensions, it looks like this. You observe that there are 3 maxima peak red colors and 2 minima peaks. They are in blue colors. Okay. So our objective is to find out this global maxima, which is there here, and global minima, which is there here. So how we will determine this global maxima and global minima? If we will apply the mathematical derivative based methods like Newton-Raphson method, Gauss-Jordan method, steepest descent algorithm, Gauss-Newton method, or other mathematical method, they will fail because they all are based on this derivative dy by dx, slope of the curve. Based upon that, they all are based on. Okay. So in this particular case, we will think for an algorithm which will be giving us better result in multimodal system identification, or multimodal case, it will give us better result. So what we will do, that in this particular curve, we will put so many elements. You observe, I am putting 6 different elements. These elements may be ants. Okay. You have seen tiny ants. They all move together in a line, one after other, one after other. They all move and they carry the food from the food source to the destination. That means they are wholes. They all move in a line. Okay. So why they all move in a line? Because they have to carry all the foods from the food source to their nest. Okay. So when they all move in a line, nobody has observed that they move in a line which is an optimal line. That means from the food source to the a nest, that line on which they move, that is the shortest path between, that is the shortest path. So that ants, they all together make communication among themselves. They create a environment in which they will move all the food from the particular food source to the next in a optimal line. So tiny ants, they can do the optimization task. How they do it? They collaborate with each other. Not a single ant can draw that particular line, but all ants together they do that particular task. So if we will keep some sugar particles in this particular global maxima, here I have added some sugar particles, okay, and I have kept some ants in the form of the elements, okay, then what will happen? All the ants over here, they will try to move to this particular point, okay, and thereby they will find out and tell us that here is the global maxima. So this is how the optimization as nature inspired optimization. It is inspired from natural phenomenon like the ants movement, the birds how they fly. Based upon that, this has been initiated. A lot of you see these complicated problems. This is egg holder problem, dropway problem, alpine problem, Greenwich, Rastigen, De Jong. In these problems, there are many maxima and many minima are there. Not a single up and down, but many up downs are there. So among these many up and downs, which one is the best? That how we can able to find it out by the help of these particular algorithms. So many researchers have worked on all these principles. Okay, some of the algorithms, popular algorithms are evolutionary algorithm. Evolution from parents to the next generation children to the next generation children. It is inspired from Darwin's theory of evolution. That is survival of the fittest. How things will survive. Okay, that means at once upon a time, dinosaurs and human being both were there on this planet Earth. But with respect to the change in environment, dinosaurs could not able to change themselves. But human being, they used to change themselves. So that's why they survived till now. So based upon this change, survival of the fittest, whoever is fit, that will survive for long. So based upon this principle, this evolutionary algorithms have come into account. Then there are physical algorithms. That is how there are physical phenomena that inspire us for optimization, like gravitational search algorithm. Everybody know the gravity forces that between different planets there is capital G is working, that how the gravitational things they balance each other, the gravitational forces how they balance each other. From there we can derive a optimization algorithm. That algorithm is known as gravitational search algorithm, very popular. Swarm intelligence, that is collective nature of collective behavior of a lot of birds, a lot of ants, like that how they are intelligent. From there we will collect the inspiration and follow this particular principle. Then nowadays in the COVID time, everybody talks about immunity. Can we able to design artificial immune system, okay, and design algorithms which are inspired from the artificial immunity to solve our engineering problems? Then there are many other algorithms like cat, swarm optimization, inspired from bat, inspired from firefly, inspired from cuckoo. Many other natural search agents are there. How they perform optimization task in their real life? Can we able to get inspiration from these particular animals and derive algorithms that will solve our problem? Now here in these tables, I have shown you two important things. One is this single objective, and another one is multi-objective. So solving solving one particular optimization task is a single objective algorithm. If we try to optimize 2 to 3 objective function simultaneously, then that is known as a multi-objective algorithm. So both the things I have taken into account. So one of the very popular algorithm is a genetic algorithm, which is inspired with Darwin's theory of evolution, and John Holland is the father of genetic algorithm. And Davis Goldberg, his student, he has also popularized this particular algorithm. And everybody know that it is here the solutions are a chromosome which is comprised of many genes. So this binary string, which is 1010 binary numbers, that will use to solve our problem. So this is how the initial solutions are generated in a genetic algorithm. Suppose we are trying to find out a multimodal function optimization. So here you see this is a very simple function, sin x1 plus cos x2. How to find out the minima of this particular function. So this function we have plotted in 3D, then this is the minimum point. You observe this, we have to find out that here there is minimum of this particular point. And what is the solution? When x1 is equal to 3 pi by 2 and x2 is equal to pi, okay, 3 pi by 2 and pi, at that time this function attains a value minus 2, which is the minimum value. So on these two variables x1 and x2, if you will observe this triangle, this is the minimal point. Okay. So over here, how to solve that particular one using genetic algorithm? Here we have two variables. So you observe that here there are two variables, x1 and x2. So for x1 we have taken a number of chromosomes, then for x2 we have taken a number of chromosomes. So both the things, then we have converted them into decimal numbers, okay, binary to decimal number, and solve this problem in the range 0 to 2 pi, because 0 to 2 pi is the range in which we try to optimize these particular functions. So now for all these chromosomes, we have found out the fitness value from F1 to F5, and then perform very interesting operation known as crossover. Okay, so for this we have taken a point of thing, and the upper part of it we will take to lower one, and lower part of it we will take to the upper one. Okay, like whatever is happening in this particular slide, you see upper part is coming down and lower part is going up. Thereby we have created new solutions. With these new solutions help us, that new solutions are children's. The children's are more smarter than parents. You agree to it? Because our childhood time, there were not so much of smartphones. We didn't know much about it. But now these generation children, they use very good in using these smartphone apps. They are much faster than us. So with these crossover children, they are much better than parents to find out better solutions. Then next process is mutation. So we have to do certain calculations so that they will avoid those local minimas and try to achieve the global optima. So we find out over here that whenever there is a random one position is there, you convert that one position into a zero position. If there is a zero position is there, randomly convert it into one position. So thereby you have changed certain bits. Like here, there is a change in bit from red to green. So thereby you have created again a number of solutions. So now some original solutions were there, and you have original solutions we have taken, original parents, and we have generated some crossover children, and we have generated some mutated children. All these people we are combining and take some of them to the next generation. Best fit, whoever is best fit, original parent is best fit, or the new generation children, they are the best fit. Whoever is best fit, that will go to the next generation. So this is how the genetic algorithm performs, that you have to initialize, then crossover, then mutation, and go on repeating it until and unless you get the solution. There is another very interesting algorithm known as particle swarm optimization, that is also a nature inspired algorithm. You see, whenever this is inspired by Kennedy and Eberhard, two researchers, they have invented this particular algorithm, Kennedy and Eberhard, and there are a lot of books and IEEE transactions published by them. Okay, so this is inspired from how the fishes, they behave in a particular pond. So whenever you go to a pond and you throw some food particle, this is a food particle that is thrown by you, do you see that there are many fishes are there in this particular pond? So whichever fish is close to this particular food, that will say that, oh, I have got some food, and how much amount of food I have got, that is small amount or big amount, that will go there and inform its friend that, look, I have found some amount of food. So you see, it moved there and informed its friends. Then all of their friends, they moved there. Okay, and they all have the food together. So today one fish got some food, he has given it to all his friends. Tomorrow another fish will get some food, that will also give it to its friend. So by sharing the food among themselves, they can survive for long. If today one fellow got food, that is taking the food, that is not sharing with its friends, then tomorrow another fish that is getting food, that will also not share. So thereby they will get starved. They may die with respect to time. So they share their food among themselves. So this particular phenomenon has been formulated mathematically. You see that here there is a pond. In this pond, this red color dot is our food. And the fishes are normally shown over here with everyone has a position and everyone is moving with certain velocity. Here, there, they are moving. And after certain time, you observe that all the fishes, they all are moving towards the food. In the third diagram, all are moving towards the food and to have them together. I hope this principle is very, very clearly understood. So over here, mathematically, we have two equations. That one is their velocity update equation and another one is their position update equation. Initially, the fish's velocity get updated and then followed by this updated velocity gets added to the position, and thereby they all move towards finding out the particular solution. So this is the flow chart of the particle swarm optimization algorithm, with which the particles, they move towards the global solution. So like that, but this algorithm, there are many other algorithms are there, like ant colony optimization, artificial bee colony, bacterial foraging optimization. Many algorithms are there. They do have their own steps, and if you follow their steps, then you will get effective clustering solution or effective optimized solution. So when we apply this particular thing, you have to download your data sets from this benchmark data set of UCI machine learning repository. There are many databases are there in this particular website, and you can download them. And these researchers have already applied genetic algorithm, PSO, many other things on these particular data sets. This Irish data set, I have discussed with you the flower data set. Like that, there are wine data set, there are glass data set, there are image segmentation data set, there are many diabetes patient data set. Okay, so you can able to know that which patient have diabetic symptom or not. Like that, there are many applications of clusterings are there, like image segmentation. There is a wireless sensor network you can able to apply, mobile network you can able to apply, gene data you can able to apply for analysis, geophysical data also you can able to do analysis. So like that, many real life applications of clustering algorithms are there. So your problem can effectively apply to this for solving these particular problems. So this is a research paper I have written, which has got a much popular, and more than 500 citations have been received by this particular research article in last couple of years. So it is a survey of nature-inspired meta-heuristic algorithms for partitional clustering. So a lot of recent algorithms which have been applied in this particular field, I have given in this particular research paper. So those who are interested, they can able to read this particular research paper. So my research group over here also, they have worked on many other algorithms like social spider algorithms. So from spiders behavior also we have converted those things into a form of algorithms. And we have observed that based on the spiders behavior, that how the males and female spiders they behave, based upon their behavior, the algorithmic development we have done, and then applied that one for clustering, which have given us very good interesting results. So this is the spiders, all of you know, they lie on a particular wave, and there are males and female spiders. You see that this black one are male spiders and this brown one are female spiders. And there are baby spiders which also get formed. Okay, so this is a female biased society based behavior on the social spider algorithm, because many of the 60 to 70% of the populations are female population in the spider colony, and 30% are only male population. So based upon that, the initialization is done, and here this is the fitness function that has been used for minimization of the distance for performing the clustering task. Then the algorithm steps are defined over here, that the spiders they communicate with their nearest female counterpart to perform their movement. So you have to move towards the local spider near to you and the global spider near to you, so that you can able to effectively able to communicate. So how the communication happens? By tabbing on the wave. So you tab on the wave, and that tabbing will be reflected on all the people. So this is the local and global way of communication of the spiders. Okay, so now the male particular spider, they communicate with the female spider also, and these spiders they do communicate among themselves. So this is how the female spider movement equation, update equation is there. Okay, so this is how they mathematically move, the female spider on the wave. The male spider, they also do their update with this particular equation. This is how they move on the wave. And this is how the baby spiders, non-dominated spiders, they move on the wave. Okay, so they move here, there, and do the optimization task, and baby spider gets formed. These baby spiders, they take care of the best solution, whatever is the mother's position. So the mother's position, best position is you observe 36% is the highest best position. So the baby spider takes the most of the thing of the mother's position. So in the original algorithm, this particular thing was implemented in serial manner, one after the other, male update, female update, and non-dominated male update. These update equations were in sequential manner. So in our proposed algorithm, we have done them parallel, thereby saving the time of the thing. And the computational complexity of the algorithm we have also reduced. We have applied them on benchmark data sets for clustering. So you can see this interesting results that we have used. Many of the clusters, they are found, they are effective in nature. And we have done it in less time also. So you observe over here that in the original algorithm, it was taking 44 seconds, whereas our implemented algorithm is taking less time. And we are getting almost similar accuracy. Okay. So with similar accuracy, we have within the less time, we have solved the problem. We have applied it for satellite image segmentation. So you can observe that here is a, on the left side, it is a flood affected area of Chennai. We have captured the image. On the Chennai airport was submerged in 2015. There was heavy rain over there. So this is the image captured on October 21 before the flood, and this is on December 8, 2015 after the flood. So when we have segmented, we have observed that this is the water retention capacity before the flood, and this is the water retention after the flood. So you observe that the lakes, these are the lakes. So you see the lake and the river banks, they have got so much increased in this particular region. And near, this is the seashore, and near the seashore there are a lot of region in which the water is increasing. So if we can effectively find out such regions timely, we can evacuate the peoples who are lying near the seashores where this water region is growing. So like that, there are many real life applications. This is one of the very important application of satellite image segmentation to which we have applied this clustering problem. So these are some of the very important research papers our group has published in last couple of years of Elsevier and IEEE. You see IEEE journals and benchmark Elsevier papers in last couple of years. We have also published in benchmark international conferences in India and abroad. So that much from my side. Thank you, everyone.
Thank you, sir. Thank you very much. Yeah, yes, sir. Thank you very much for the exhaustive lecture, sir. Because the reason why I call it as because though it is crisp in a 45 to in a 50 minutes, but still there is a lot of information that you have given that is sufficient enough for loads of years of work. I could see right from 2014 the advancements. I mean, the advancements in these evolutionary computing tools, and I could listen to some new things, new words, and new algorithm names, a variety of algorithm names. Yes, they are not actually. We are used to some such kind of different names in evolutionary computing tools, but you have introduced more latest algorithms to us. Definitely, we would like to try and apply these algorithms to our already existing problems in electromagnetics and communications. And your paper on that filtering using evolutionary computing tools has been a benchmark for us for many days, for many years, and many of our UG and PG students, they are working on it. And your thesis has been again one more benchmark for us, because that has been a big reference to many of the people who are working on evolutionary computing tools and applications to several fields. Because though your work or whatever that you have discussed now seems to be specific to communication, but it is not so, but very much widely applicable. In fact, what the only thing is, you have to just replace the problem statement with another problem statement, but the entire reference or the template remains the same. That's what we experienced
Yes.
from years, in fact. Because I have attended to your lectures when you are there as a PhD scholar, when you have done a PhD, when you have submitted PhD, when you are awarded PhD, and when you are a teacher, when you are a postdoc. And all this, I have seen a lot of change in your a gradual increment in the way you are presenting the data. So that was, and the way you, I mean, probably how, I don't know how many of these people might be knowing about the practical sessions
Yeah,
that you
those
have.
are very, very interesting.
Yeah, yes, sir. The way
And
you,
nowadays, actually, the Ministry of Electronics and IT has given us a 10 crore project.
great.
That is known as Electronics and ICT Academy.
Yeah,
So that yeah, that is given us at MNIT. That is also given to NIT Warangal also. So with that, we are conducting a lot of faculty development program from last 4-5 years. So in those also, we are rigorously putting those lab sessions along with Professor Ganapati Panda sir. And similar practice, but every time nowadays this has become online, so that all your people can also join online and can able to get the benefit of it.
sir, is there any specific restriction that we belong to NIT Warangal region and we cannot associate with you? Is there any?
No, not like that. You can associate with any academy. It is free all over the India. There are 7 academies are there. You can collaboratively do from any thing. No problem with any academy.
Sure, sir, definitely. We experienced when we were doing PhD and when we have visited your campus, your place, your room, and when we experienced your lab sessions. They are really amazing. I still remember you walked through the hassle of the laboratory and dictating the code, and we all used to, throw our hands onto the keyboard. And we are delighted with the way you have the habit of asking us to write the code step by step, which put together comes around eight steps, and finally you give a single command that replaces all the 8 steps. 8 lines of code. Yeah, that linspace and all the genetic algorithm. We still remember all those days, sir.
Yes.
So fortunately you are here. Unfortunately, we could not ask you physically be here, but next time we'll do that, sir. And sir, now we'll move to the valedictory, and we have Lakshmi Narayana Sadasivani, who is the professor, and he is the chair of IEEE Vizag based section. And it's just a crisp 15 minutes valedictory function, sir. So I hope you don't mind your
Sure. Please, I will be there.
Yes, sir.
Continue.
Sir, Lakshmi Narayana, sir.
Yeah. Good evening,
Yes, sir.
Professor Nanda and Professor Samir and Professor Chaudhary Garu and others who are there. My video is, you can see my video?
Yes, sir.
Yes, we can able to see, sir.
Okay. In fact, it is a proud moment for us all. In fact, Vizag Bay subsection became a section last year. And I think many of you are aware of most of the authors are aware that this is the first conference we are basically conducting in outside the premises of in a private institution. I am aware that this institution is very good in this geographical region, and the management, the faculty, the team are excellently doing the good work, no doubt on that. But as a valedictory function, basically what we want to listen from the participant than telling us what is done here. Certainly, you are aware that we have the team has done a great job, and a small team. In fact, many of the authors might be knowing our team strength, etc. Our section is small, our team is small, but still we could able to do a very good program, and fortunately we received a good number of papers because of the good relations of our team members. Certainly that is true, and they basically got a good number of papers across the world, and they could publish a good number of these things. A good teamwork, and typically around 100 reviewers are there for reading the papers. All the papers have been reviewed thoroughly. There was no compromise about the quality of the papers and the quality of the content. Certainly, we are basically myself and Satish Chowdhury and Samir are really looking step by step, and things are went well. Due to Corona, we basically felt a little uneasy because we could not host in person to all of you, see all of you. Certainly, we miss you in person. Certainly, not miss you in hearts. We know that all of you are with us. But old. What basically see the authors, how old is the conference, what that series in the conference. That was one of the factor what many people see in the conferences. Therefore, I am requesting that to our team, particularly, I am also one of the team member, the institution and management also, I request them to consider again the same event in IC3P 2024. Maybe by the time, certainly, I'm sure that COVID will close and we will all can see physically. Vizag beaches are excellent to see, no doubt on that. And our team is excellent to take you all around. We have a place called Aruku and Paderi, etc. Very good places nearby. Certainly, we have a good place. And all the papers, what in fact, yesterday night I glanced at some of the abstracts of the papers. I really felt they are much deserving to be published in a good transactions also, some of the papers. They have really have a belief, that was the reason they sent to us. Those papers will give us a strength and image for us, and in fact that gave a value for our conference. Tomorrow, if IC3P 2024 comes, people will typically see that what is the usage value of IC3P 2022. Certainly, these papers will be seen much more than many other conferences in India, but in particularly. I'm basically the team of us, maybe a short, small team, is really wondering and struggling for keeping the quality in our conferences. I feel that most of the authors might be seen. I also request some of the papers, they are deserving but could not be accepted because of the ratios what we see and the comparative merits what we see. I don't say that those papers are not good, but unfortunately we have a limitation of time of 2 days, and we have to give a 10 minutes time and 5 minutes time. These are the constraints who made us to accept only approximately 60 papers per presentation. Even though we kept some of the this thing into a parallel sessions too, we did it. But there are certain limitations of we should not normally any IEEE conference doesn't cross a 30% of the this thing. This gives us an image and faith and confidence for us to run a show in 2024. This mind, suppose if we accept all papers, whatever tomorrow, 2024, you may feel that this conference has no much value. That was the reason that these are the things what we have taken care. At every point in time that we took care of all these things. I certainly the chairman of the regional Raghu engineering institutions, both institutions. Sri Raghu Kaladandi Garu was also the backbone of this entire the conference. He was one day, my colleague Satish Chaudhary and Samir was mentioning. I asked early stages, what is the money, what is the part you can spend for the conference? They said one thing to me, it is not fixed. Whatever is deserving, what is needed can be spent for that. I was really fortunate to have such a management to extend such a support for us and doing that. With that confidence only, I could basically do that. But typically, I apologize if there are any mistakes done by or errors, omissions by the committee, by the members in bringing you online or taking you offline, etc. We certainly will correct those things in future our conferences in case you mail us and tell us what could be the best way to do that. Certainly our themes are fixed, our ideas are fixed. Therefore, all authors, I request you once again to kindly prepare a very good manuscript. I think I will request Satish Chaudhary also. This time we will have a little more number of pages, little more, not limited to 4. We should put 6 to 8 pages of the paper so that little more work can be extracted from the authors and many people can see. Our acceptance rate is excellent and our papers are also very good. And I hope you enjoyed our conference in this year. Really, I thank you all. But before to that, I would like to know any of the things or any tell us so that it is not, please do not think you are commenting us. You are really helping us in making the conference in 2024 in a better way, the way in which you like to have in my side. Certainly, you are all welcome to back to Visakhapatnam in 2024. Thank you very much, in fact. Thank you very much, sir. Over to Samir.
Sir, thank you very much, Lakshminarayan, sir. So, myself, so good evening all. So, myself, Professor P. Satish Ram Chaudhary, Journal Chair for this IC3P conference. First of all, I would like to thank our chairman Raghu Kaladandi, who has given us an opportunity to conduct this conference at our institutions. Our director Rahul Kaladandi, and it is really very happy to say that the highest person of the education, Chairman Professor K. Hamchandra Reddy, APCHE, and Professor H. Prasad Raj Garu, Vice Chancellor, and APSI Vice Chairman Professor Ramohan Rao Garu are aware of this conference and they have given their messages also. So I thank once again all the invited speakers, Dr. Jam Angwera, Dr. Kiran Gunnam, and Dr. Satya Jagannath Nanda, who has given their valuable talks in this last 2 days. And I congratulate and I wish all the authors who have presented their papers in the online and offline modes. Hope we have given you good atmosphere to present your papers. And I think the best part of this conference is
Satish Garu, 1 minute, Satish Garu. I think all authors to kindly wait for the next announcement for the uploading of the papers.
So that I will tell, sir. That I'll ask
Dr. Samir and Satish will send you the link. Okay, sir. Okay.
So
go ahead.
Yes, sir. So once again, I thank all the authors.
Go ahead, Samir, Satish Garu.
Yes, sir. All the special session chairs, Dr. Sudhir, Dr. Subbarao, and others also. And I thank chairs and co-chairs who have made the sessions to go in a smooth way and timely organizing the sessions. I thank the technical and non-technical people who have supported this conference behind the screen and make it a grand success. Even though we are conducting in a hybrid mode, there are a lot of logistics that have to be taken care behind the screen. And there are a lot of people starting from all heads of the department of both colleges, our technical staff, Harsha, Manikanta, Ramesh, and all others. I thank one and all. Forgive me if I forget any name. And we hope, we are very sure, Raghu as a group, we are very sure of organizing such conferences in future with collaboration of IEEE Vizag Bay. And finally, I would thank my sincere thanks to Professor Lakshmi Narayan Garu, who is behind us in noting this name as IC3P conference, starting from that point till date. And I thank Professor KV Sriram Garu, CEO Andhra Electronics, who have come all the way from Kakinada to attend this conference yesterday. And Abraham Varghese Garu, NSTL, who has been beside us in doing it so. And all the SEC members, Chisti, and Professor Murthy from JNT Kakinada, Professor Deepika Rani, and all other members, and Professor Sandeep from MNIT Warangal. So there are all members who have worked behind the screen to make this conference happen. And once again, I thank one and all for making this conference a grand success. Now I request Dr. Samir to sum up the things.
Yes, sir. Thank you very much, Chaudhary Garu. And thank you very much, sir, excellent, sir. And thank you very much, IEEE Vizag Bay section. And to the others, there is a small instruction that the CRC have to be uploaded on the CMT, and we are waiting for it. In fact, almost 90% of the others have uploaded, and few are left, and the mail correspondence has been done, and you are supposed to act on it by the end of the day. And further, the copyright form and all the instructions will be conveyed to you by email. And please do follow the timelines, because your quick response is what counts on the time gap between the conference date and the publication time. So this is what we usually expect from you. And we have taken utter care by keeping a team of members to help you out in getting the paper in format, but still it is not sure until and unless we do it with the proper PDF Express, which we have registered in the conference name. And in future, in few days, the details of it and the information related to the PDF Express, everything will be shared with you. You please be in touch with us, and please respond to the mails that we daily sending to you. Your quick response is what we expect from you. Yes, sir. Anything to conclude, sir? Lakshmi Narayana, sir?
Yes, it's enough. That's what exactly I thought that this point we need to tell to all the authors.
Yes.
Is it true? One point you have mentioned very clearly that all authors, if they respond very fast, the timeline will be shorter to show all papers to the explore. That's it.
Yeah. The reason why we haven't asked you to upload it on CMT, the CRC, is very simple. That none of the papers were in format, and we have a team that who were working on it constantly for the past 15 to 20 days, just to help you out in getting the paper in at least in the 90% of the shape required for the IEEE standards. And then now you are asked to do so. So during the
also Samir Garu, also I request authors also to kindly note if any chairs of the session or any of the comments made during your presentations, you can have a small changes in your paper.
Yes.
In the text only, please do not change that to title and authors. Suppose some chair has given a recommendation to do something, you can add a 10 words or 15 words in between the paper and do that.
Yes. Okay, sir. So that is what to conclude, and I am really thankful to Dr. Satya Nanda Garu, because he has been with us. His presence in the valedictory function really makes some sense. He is also a part of the TPC. He has given a quick consent to us when we approached him to be a TPC member, and he helped us because I have been in touch with him right from changing the dates and extension of dates. All these things I kept on inform him, and finally it is also made possible for us to invite him for an online session. So really I'm thankful to you, sir, because all the dignitaries during the valedictory sanction usually who are present for all these days, they are not available now, and that's the reason why we have intentionally, scheduled the invited talk just before the valedictory. So just to ensure that you being associated with the one of the committees of this IC3P, as well as a very good friend and mentor of many people here who are there in the Department of EC of Raghu Institute of Technology, and you have been really accessible to us, even on phone. You did pick up whenever it is required. We are in need of an advice or suggestion from you, and you have really quickly accepted our consent even for the invited talk also. Thank you very much,
Thank you.
and we are really blessed to have you here, and we'll be in constant touch with you, sir, for many programs in future.
Thank you, sir.
Thank you, sir. So I conclude this, and others will be in touch with you. And thank you very much, excellent sir. Yes, sir. So with your permission, I'll be ending the meeting, sir.
Vote of thanks అయిపోయిందండి.
Yes, sir.
Okay.
Yes, sir.
Okay.
Thank you, sir. Thank you.
Right అండి, రైట్. థ్యాంక్ యూ.
Thank you, one and all. Thank you very much.
Shall we go out of the meeting?
Yes, sir. We can leave the meeting.
Okay. Thank you very much.
Thank you, sir. Thank you, sir.